Good day to you children. In today's class, we will be learning about surface area of a sphere. In the last class, we looked at surface area of a right circular cone. And today's topic of discussion will be surface area of a sphere. As we know, sphere is the shape of a ball, and in case of a sphere, the surface area is given by area is equal to 4 pi r square. In case of sphere, we don't say curved surface area or total surface area. The area of the surface of the sphere is given by the formula 4 pi r square, where r is the radius of the sphere. Now, when it comes to hemisphere, that is half of a sphere, then in case of a hemisphere, this distance is the radius, this distance is also the radius. In case of a hemisphere, we will be talking about a curved surface area which will be equal to 2 pi r square, because area of half of a sphere, so it is 2 pi r square. And when we talk about the total surface area, then it will be equal to this curved surface area plus the bottom circular shape, so it will be equal to 3 pi r square. So these two formulas are used to find the curved surface area and the total surface area of a hemisphere, whereas this formula is used to find the surface area of a sphere. So let us look at example 7. Find the surface area of the sphere of radius 7 cm. Given r is equal to 7 cm, we know that since it is a sphere, area is equal to 4 pi r square, which is equal to 4 into 22 by 7 into 7 into 7. 7 square r square can be written as 7 into 7. 7 ones are 7 ones are. So what we have is 4 into 22 into 7, which will be equal to 88 into 7, which will be equal to 7 8s are 56, 5, 7 8s are 56 plus 5, 61, 606 centimeters square. This is the solution to the 8th solved example. Now next solved example, that is the 8th solved example. Find the Csa and Tsa of a hemisphere of radius 21 centimeter. Given radius 21 centimeter of an hemisphere, we are supposed to find its curved surface area and also its total surface area. So for curved surface area, we know that it is equal to 2 pi r square, which is equal to 2 into 22 by 7 into 21 into 21. 7 ones are 3s are. On multiplying everything, we get the Csa of the hemisphere to be equal to 2772 centimeters square. And so now the total surface area will be equal to 3 pi r square. So this will be equal to 3 into 22 by 7 into 7 into 21 into 21. So 7 ones are 3s are. So this will be, on multiplying, we get the total surface area to be equal to 4158 centimeters square. So this is the required solution for the given question. In example 9, diameter of the sphere is equal to a hollow sphere in which the circus motorcyclist performs his stunts has a diameter of 7 meters. So diameter is 7 meter. Find the area available to the motorcyclist for riding. So the motorcyclist is riding inside a sphere whose diameter is 7 meter. So the area available to him will be the total area of a sphere. So first we know the diameter, so radius is equal to d by 2, which is equal to 7 by 2 meters. So now we know that area is equal to 4 pi r square, which is equal to 4 into 22 by 7 into 7 by 2 into 7 by 2 r square. 7 ones are 1s are, 2 ones are 11s are, 2 ones are 2s are. So we have 14 into 11. So this is equal to 11 4s are 4, 4 carry, 11 1s are 11 plus 4, 154 meter square. So this is the area available for the motorcyclist to perform his stunts. Solved example 10. I am leaving it to you as your homework. You can pause the video and work through it right now. So we will be directly going to exercise 13.4. Exercise 13.4. The first and second questions. The first main and also the second main, I am going to leave it to you as your homework, because in these questions they have given the radius as well as the diameters of the spheres, and they have asked you to find the surface area of those spheres. So it is pretty straightforward questions which I will be leaving it to you. Pause the video and solve them right away. In the third question, find the total surface area of a hemisphere of radius 10 centimeters. So we will move to the third question. Radius of the hemisphere is 10 centimeter. Take pi to be equal to 3.14 and find its total surface area. We know that Tsa of an hemisphere is equal to 3 pi r square. So this is equal to 3 into 3.14 into 10 into 10. So this is nothing but 3 4s are 2, 1, 3 1s are 3 plus 1, 4, 0.33s are 9 into 100. So this is equal to 942 centimeters square. So this is the total surface area of the hemisphere whose radius is 10 centimeters. In the fourth question, the radius of a spherical balloon increases from 7 centimeter to 14 centimeter. So in the fourth question, radius 1 is 7 centimeter and radius 2 is 14 centimeter, because we had a spherical balloon of radius 7 and its area or its radius increased to 14 centimeters. As air is being pumped into it, because it was pumped with air, find the ratio of surface areas of the balloon in two cases. So first, area 1, since they are spheres, area 1 is equal to 4 pi r1 square and area 2 is equal to 4 pi r2 square. Our job is to find the ratios, so divide them. So now we get a1 by a2 is equal to 4 4 cancels each other, pi pi cancels each other. What we will be left with is 7 by 14 whole square. So this is equal to 1s, 2s, 1 by 4. So therefore area 1 is to area 2 is equal to 1 is to 4. This is the required solution for the fourth question. Moving to the fifth question, a hemispherical ball made of brass has inner diameter 10.5 centimeter. Find the cost of tin plating it on the inside at the rate of rupees 16 per 100 centimeter square. So in this question, they have given us a tin bowl. This is a tin ball which is in the form of a hemisphere. And its inner radius, this inner radius is equal to, the inner diameter is equal to 10.5 centimeters. So this implies, since diameter is equal to 10.5 centimeter, radius is equal to d by 2, which is equal to 10.5 by 2 centimeters. So this is the radius. We are supposed to find the cost of tin plating the inner surface area. So when we are talking about inner surface area, we are only considering the curved part and not this top circular part. So we are supposed to find the cost of tin plating the curved surface area of the hemisphere. So Csa is equal to 2 pi r square. This is equal to 2 into 22 by 7 into 10.5 by 2 into 10.5 by 2. 2 ones are 2 11s are 2 ones are 2 ones are 7 ones are 1.5. So all we have is 1.5 into 10.5 into 11. So which is equal to into 11. This is equal to 173.25 centimeter square. This is the area of the hemispherical bowl. So if for 100 centimeter square the cost is rupees 16, then for 173.25 centimeter square the cost of painting will be x. On cross multiplying we get x into 100 is equal to 173.25. So this is nothing but x is equal to 173.25 into 16 divided by 100. So what do we get after that? So we get the value of x to be equal to rupees 27.72. This is the solution to the fifth question. Now coming to the sixth question, find the radius of the sphere whose surface area is 154 centimeters square. So we know that area is equal to 154 centimeters square and we are supposed to find the value of radius. We also note that area is 4 pi r square. Substituting the values, area A is 154 is equal to 4 into 22 by 7 into r square. So this implies on transposing and rearranging everything we get 154 into 7 divided by 4 into 22 is equal to r square. So here 2 11s are 2 7s are 14 carry 1 7s are. So 11 ones are 11 7s are. So this is nothing but 7 into 7 49 by 4 is equal to r square. So since r square is 49 by 4, we can r will be equal to under root 49 by 4, which is equal to 7 by 2, which is nothing but 49 by 4. So root of 49 is 7, root of 4 is 2. So this is 7 by 2, which will be equal to 2 ones are 3.5 centimeters. So therefore the radius of the sphere is equal to 3.5 centimeter. This is the solution of the question number 6. In the question number 7, the diameter of the moon is approximately 1/4 the diameter of the earth. So in the 7th question, they are told us that diameter of moon is equal to 1/4 the diameter of earth. So we are supposed to find the ratio of area of moon to the area of earth. So since we know diameter of earth is d, then radius of earth, so then the radiuses will be radius of moon is equal to diameter of moon by 2 and radius of earth will be equal to diameter of earth divided by 2. Here diameter of moon by 2 means diameter of moon, we have written it here, 1/4 of DE. So it will be 1/4 into DE into 1/2. So this will be equal to DE by 8. 4 2s are 8. 8 and radius of earth is DE by 2. That is diameter of earth by 2. So now area of moon will be equal to 4 pi rm square and area of earth will be equal to 4 pi re square. So taking the ratio, that is by dividing them, we get this will be equal to 4 cancels, pi cancels, rm can be written as de square by 8 square divided by divided by DE square by 2 square. So this, from this we get DE square, 8 square is 64 into, we'll take the reciprocal, 2 square is 4 by DE square. So DE square cancels each other, 4 ones are 4 16s are. So this is equal to 1 by 16. 1 by 16. Therefore, area of moon to area of earth is equal to 1:16. This is the required ratio. In the 8th question, a hemispherical bowl is made 8 centimeter, 0.25 centimeter thick. The inner radius of the bowl is 5 centimeter. Find the outer curved surface area of the bowl. So just like in our tin bowl problem, here we have a hemispherical bowl whose thickness is 0.25 centimeters. So this part, this is the thickness of the bowl and this is equal to 0.25 centimeter. Whereas the radius of the bowl radius is equal to 5 centimeter, that is the inner radius. So our job is to find the outer curved surface area, that is from here to here, outer curved surface area. So here to here, the area which is formed by this radius, this outer area. So to do that, to find the outer curved surface area, we will have to find the outer radius or the total radius of the bowl. So the total radius or the capital radius is equal to inner radius plus the thickness, which is equal to 5 plus 0.25, which is equal to 5.25 centimeter. So now the outer curved surface area of an hemispheric bowl, Csa, is equal to 2 pi r square. So this is equal to 2 into 22 by 7 into 5.25 into 5.25. So now to solve this, let us convert these decimals into fractions. So 2 into 22 by 7 into 5.25 can be written as 522.5 by 100 into 525 by 100. So 2 ones are 250s are 250s are 2 11s are. So 7 ones are 7 sevens are 49 49. So carry 3 35. So this is 75. So now here we can further resolve it. 5 tens are 5 ones are zeros are 5s are 105. Similarly 5 tens are 5 15s are. So once again 5 twos are 5 threes are 5 twos are 5 twos are 1s are. So what remains in the end is this is equal to 11 into 3 into 21 divided by 2 into 2. So on resolving this we get 11 into 3 into 21 is equal to 693 divided by 4, which is equal to 173.25 centimeter square. This is the outer curved surface area of the hemispherical bowl. So the last question of the exercise, the right circular cylinder just encloses a sphere of radius r. In the 9th question, we have a right circular cylinder. If you can see the image in your textbook, a right circular cylinder just encloses a sphere of radius r. So this is the sphere of the radius and this is the radius r, and this is the cylinder whose radius is also r. Find the surface area of the sphere, find the curved surface area of the cylinder, and also the ratio of both the areas. So in the 9th question, the surface area of the sphere. Since its radius is r, then area is equal to 4 pi r square. Area of the sphere is equal to 4 pi r square. Similarly, in the second part, they have asked us to calculate the curved surface area of the cylinder, and the curved surface area, or the CSA of the cylinder, is given by the formula 2 pi RH. Area of sphere is 4 pi r square, and area of cylinder is also equal to 2 pi RH, but where h is the height of the cylinder. But as you can see in the figure, the cylinder encloses the sphere. That means area of cylinder is equal to area of the sphere. So 2 pi RH is equal to 4 pi r square. 4 pi r square, because see here, the height of the cylinder, this h is equal to, this is also radius of the sphere and this is also radius of the sphere. So h of the cylinder is r plus r, which is equal to 2r. H is equal to r plus r, 2r. So on substituting, we get 2 pi RH to be equal to 4 pi r square. So area of the cylinder is equal to area of the sphere. So lastly, we are supposed to find the ratio. Lastly, we are supposed to find the ratio of the areas obtained. So ratio of area of sphere to ratio of area of cylinder, AS upon A cylinder, is equal to 4 pi r square by 4 pi r square, which cancels each other. So we get 1 by 1. Therefore, area of sphere is to area of sphere is to area of cylinder is equal to 1:1. This is the solution to the final question. So this completes your exercise 13.4, and I hope you solve the questions which have been given to you, or which I have left as a part of your practice exercise. In the next class, we will begin with volume of a cone and we'll end the chapter with volume of a sphere. So that's all for today. Thank you.